Hello everybody, my name is David Calvert. I'm a co-director and founder of iFormulate based in the UK, and today I'm going to talk to you about the changing face of agrochemical formulation. Just before I start that, I'd like to thank the organisers for asking iFormulate once again to make a presentation at your Congress, and I hope it is going well. So, as you might expect, I'm just going to give a little introduction about iFormulate. We were formed in 2012 by myself and Jim Bullock, who's presented to you in the past few years about formulation. You can read on the slide when you get the slides about our experience. We work across all different sectors within formulation, but have a lot of experience in agrochemical formulation, and that's the subject area we'd like to talk to you about today. Our services in formulation across all sectors. The majority of our business is in consultancy, and we tend to work there under NDA with companies. So you'll see today that our information that we're going to present comes from publicly available sources. We've done some strategic work for companies, mainly in the UK. We helped with the business case for the National Formulation Centre that's in the UK, and we do training courses. They can be under our own banner in conjunction with partners, or as has become more frequent recently, we've actually done a lot of tailored training courses for clients over the web. So, enough of the introductions. What am I going to talk to you about today? Well, I'm going to start with outlining the emerging challenges and opportunities in agrochemical formulation, and to a large degree in all formulation areas. Then I'm going to give you a few examples of what the formulation community is bringing towards precision and digital agriculture, talk about the topic of microplastics, talk about biocontrol products, and then come back to you with a summary at the end. I did say that our consultancy work is almost exclusively under NDA. So all of the information that I'm going to show to you today comes from publicly available information. They can be patents, they can be websites, they can be literature and trade articles, etc., etc. But it's all publicly available if you look for it. We do not, in this presentation, endorse any specific approach or a specific technology, but what we have got in the presentation is some technologies and approaches that we find interesting. Of course, it's not a complete overview of everything that you could do to approach some of these challenges, and there are other approaches to the challenges that we know about and perhaps we don't know about, but you're actually using. So please, if you're in the audience and we don't mention about your approach or technology, that does not mean that it doesn't work. So they say in many cases that a year is a long time. That can be the case in formulation, but actually it hasn't necessarily in 1 year changed a great deal in agrochemical. The challenges are still the same, and in fact my colleague Jim Bullock last year spoke about challenges in formulation and went into more detail on some of them, and I'd like to say that those challenges are very much still there. They are regulations and restrictions, sustainability, substitution, cost performance, stability and robustness, innovation, and complexity. So I thought to start this presentation off in a sensible manner, we'll actually revisit some of Jim's slides. And I've labelled this and the following slides challenges and opportunities, because those challenges do present opportunities to formulators. Those opportunities can be either to maintain your existing business because of the challenge that's coming up, or obviously to take in new business from your competitors, or perhaps to make sure that you can take the business that is growing in that particular area. So you're maintaining it, but you're also being able to go and capture the opportunity. So, well, we all know about regulations and restrictions. They are constantly changing. They are looking for new data and evidence, and that can lead to problems, or it can also be an opportunity to maintain your business. Difficult to predict what will be next, but almost all of those changing demands from the regulators will lead to a need to reformulate, and obviously that's an opportunity. The regulations, let's face it, they are getting tougher. I don't know of many areas where the regulations are becoming easier, and that leads to, for the business, extra costs and also reduced choice to formulators. No one size fit all. There is not really a global regulation, so sometimes something may change and it'll only be applicable to one region. And regulators aren't the only ones putting restrictions on there. There are consumer demands, which may be organic, maybe eco-labeling, and certainly when you get into organic, there are multiple systems around the world. If we look at sustainability, again, a difficult one. There are some regulatory areas there, but there are non-regulatory and consumer pressure. We hear an awful lot in all industries actually about sustainability, and that can be in different formats. It can be carbon footprint, it can be water usage, it can be an impact on the ecosystems and biodiversity, and obviously an impact on people, and all of those impact on what formulators can do, and it can be the whole supply chain as well. So the raw materials manufacture, storage and transport, what happens in use, and how do you recycle and disposal. And I think when we get to the examples, you'll see a few of those in the examples. We continue substitution, which again links back to a large degree to those regulations. Co-formulants can be changed because of regulations, but also a co-formulant supplier may withdraw something from the market, or may come up with what they regard as an improvement, but that means they're withdrawing a product that you've used for a long time. So you need, therefore, the formulator needs to meet those. Also, there are cost pressures if there are increases in price, time pressures, and supply chain disruption. There's a cost performance, happens in every industry. Everybody would like to produce the same performance at a lower cost, which are fewer ingredients, cheaper ingredients, low cost processes. You're often asked to make use of existing capital equipment, and the part, sorry, a bit obscured there, but accelerate the market introduction by reducing R&D time and cost. So you're always being asked to do more with less. Stability, a large number of our projects start with the word stability, and a lot of those we have to work on what do you mean by stability, and robustness, where you may optimize a product, but it's on what they call a knife edge, and it's just not robust, so that the number of failures are unacceptable, and that leads to extra cost. You have the issue of stability both during the manufacture, the transport, the majority of people talk about storage, but also use. There are issues around stability of how to predict it and reliably test for it, and as I mentioned, you need something that's robust. Innovation, often the one that formulators would like to work on all the time, trying to get a competitive edge in your performance, trying to extend the lifetime of an active ingredient with novel formulations. So that's when your active is coming to an end of the protected life with it as an ingredient itself, but if you can put together new novel formulations, you can have added protection, and you just need to look at what happens with glyphosate, and that patent expired, I believe, in the 1990s, but there is still some IP around glyphosate, particularly around mixtures with other active ingredients. And all of that innovation, though, it's easy, and I often say that formulators can do anything, but the time and cost restrictions will make that very difficult. And obviously, formulation is a complex business. We've got many ingredients, multiple phases. You need and it's often one of the things, it's not organic chemistry where you just need to look at maybe yield and purity, but you have to balance a whole load of different variables. You need to choose optimal amount of ingredients and the optimal process conditions. And a formulator has to predict and optimize those multiple parameters: performance, stability, and cost. But all of these, you can look at it always, it's in English we say sometimes half bottle half full or bottle half empty. You can look at it as a challenge, but if you're a good formulator and you look at it correctly, then you look at it as an opportunity for you to show A, the value of formulation, but B, also how you can improve your product to beat the competition and take more of the market share. So enough of the background, but I hope that set the context, and that you'll have heard from Jim last year many of those messages, but just a little one. And in this case, and in this presentation, I'm going to focus on 3 specific examples of challenges and opportunities and how this is being approached. So let's start with precision and digital agriculture. And that word precision, the majority, the first thing that people often think about is the use of robotics or the use of drones. And although a lot of those developments are in the machinery itself, it's also interesting that formulation can play a key part in how that is delivered by the drone or the unmanned aerial vehicle. So this is a patent from, well, you can read US 2022, a patent from Bayer, and the title of that patent is High Spreading ULV, Ultra Low Volume Formulations for Herbicides. And it talks about agrochemical compositions, using on leaves, use at very low spray volumes, use by unmanned aerial systems, UAS, another abbreviation, unmanned guided vehicles, UGV, and tractor-mounted boom spray. So it's not all on precision. Fitted with conventional nozzles, but different types of nozzles as well, and their application in controlling agricultural pests, weeds or diseases. And in the abstract it talks about, in particular, on waxy leaves, and that, as many of you in the audience will know, is an added challenge. You know, formulations depend upon the surface that they are being applied to, and a waxy leaf is a difficult surface to apply to. So this one is interesting. It talks about low spray volumes, unmanned aerial systems, and waxy leaves, difficult to wet formulations. So they talk in this patent about sustainability. And what do they mean? And that's often an issue with sustainability. What do you mean by that? Well, in this case, they say that typically a typical formulation when applied is greater than 150 and can be as much as 400 litres per hectare. In this particular formulation and its mode of application, they talk about much lower spray volumes, 10 to 20 litres per hectare. Now that's great, but does it actually work? And in the patent, one of their claims is that even at this low spray volume, it does actually work, and we'll come to a little bit of the characterization later. Because of the lower volumes that are being used, there's less weight both in transport and in the application, and that, as we all know, means less fuel, so that would lead to a reduced carbon footprint. And one of the challenges for all agrochemicals is waste. Firstly, because you're wasting product you've made, and that's expensive, so the farmer is not happy about that. But also, if it goes off target, then there is a significant environmental impact, and that can be often one of the challenges from the regulators is, what about the environmental impact? It's going into the soil, what's it doing? Is it going to run off into the watercourse, etc.? And they're claiming here that because it's much more targeted, then it doesn't actually cause as much of an environmental impact. And all of those, many of those together, actually lead to a lower carbon footprint in application. And that, again, is something that is very appealing and in some regions in the world, particularly in North America, then that is also leading to there's trading in carbon credits. So if you can produce a lower carbon footprint, it also leads to a business opportunity. So what are the actual claims in that patent? They claim a ready-to-use formulation for herbicides. So that's something that you don't have to dilute. The lower level, as I mentioned, and their claim is around an organosilicone surfactant. Now we know a lot about those, and they are known as sometimes as super wetters and very good wetting agents. But they say per hectare, and it's very important that they say per hectare, there is a lower level than usual of organosilicone. The coverage on the leaves is equivalent to the high spray volume. So if you've got a lower level, but you've got the same coverage as they demonstrate, then that means that you've got less waste and you've got less potentially going to the ground or drifting off. They claim that the formulation, the ready-to-use formulation, is particularly affected on hard to wet surfaces, and we all know that that's a challenge for all formulators in the agrochemical space. They also claim that this formulation, ready to use, has improved stability and is a lower cost. And for many of the reasons we've already outlined, they talk about a lower environmental impact. So what is in this actual formulation in the claims? Well, first two components are fairly obvious. One is one or more, and they talk about what more than one active ingredients, and they name a whole load of agrochemically applied herbicides. And then one or more, and again that's typical patents speak of having one or more types of surfactants. Again, in the claims it's preferably a polyalkylene oxide modified heptamethyl trisiloxane. So those two are key, but then there is also in the formulation ready to use at least one suitable non-ionic surfactant and or a suitable ionic surfactant, and some of those are outlined in the patent itself. And then what you would expect, there are some optional ingredients such as a rheology modifier, a suitable antifoam substance, other formulants, and a carrier to the volume that is needed. And they do specify a level of the organosilicone based surfactant, which is between 2 and 15%. And again, if you're interested in this, please just look up the patent, it's publicly available. Talked initially about efficacy and how do they actually do that? Well, they've talked about how they characterize the performance of this ready-to-use formulation. To get that coverage, they put leaves in a spray chamber and they put the spray liquid, they pipetted it onto the leaf and compared the actual coverage. They used to try to visualize that a UV dye, which didn't affect any of the flow properties, and they claim to show that it has the equivalent coverage to a normal formulation. And then efficacy, well, they did greenhouse trials, they cultivated weeds for 2 to 3 weeks, and then they assessed them 3 to 4 weeks after the application. And what they saw was that equivalent efficacy, because that's what you need. You don't want to switch from one to another and endanger the livelihood of the farmer or the grower because it isn't killing the weeds effectively. But what they claim is that it is equivalent efficacy. So that, I think, in terms of precision agriculture, shows you something different from the mechanics of a drone design or a robot design. It actually shows you how a formulation can be tailored to actually bring improved performance in that area. So now another hot topic around the formulation world. Let's talk about microplastics. So I've got two patents here to talk to you about. One comes from a company called Delcis Technology, and it has that rather vague title of agrochemical compositions. So in the abstract it relates to an agrochemical composition, methods of making it, and we'll talk about how that's made, an agrochemical formulation, a method of making that, and a method of protecting crops using the agrochemical formulation. So that's all very general. Let's go into what they really do. So they start, and this is my interpretation of what they do. They start with their first mixture, which is a biodegradable polymer, and we'll give you examples on the next slides of the type of polymer they use, and then a water immiscible organic solvent, number 1. So that's mixture 1. That then turns into mixture 2, which has that biodegradable polymer. They've got a water miscible organic solvent, and they've got a water miscible organic solvent too, and that's separate and different to the first organic solvent. So you've got mixture 1, and then you generate mixture 2 by adding in those ingredients on the slide. Then that becomes mixture 3, and you have the active ingredient, they're actually doing it, and they quote specifically clomazone and acetochlor, which are commonly encapsulated. So that's mixture 3. So you've got all of these ingredients now that are all together in mixture 3, and then to make mixture 4 they add an emulsifier. So we've got a complex mixture done in a specific order with different solvents, a polymer, an active ingredient, and an emulsifier, and that's the product that would be sold. But then when you add that to water, as you would in a spray tank, then you get a fine, stable emulsion, and that's really the encapsulation taking place. And they talk specifically about a particle size, that's 10 to 20 microns. They also claim, and this is not just microplastics, but they claim that it's reduced or similar volatility to the type of interfacial polymerization you would have, and they also claim the same efficacy. So this is important when you're looking at these things. It's great to have innovation and some change and reducing or solving a challenge to produce an opportunity, but it must still deliver what it needs to deliver. So what are those components in that patent W 2024-149991? That biodegradable polymer we talked about is they mention ethyl cellulose, and there are others in the patent, but I think ethyl cellulose is the key one. Then that water immiscible organic solvent, the first one, again they specifically say it should be biodegradable. They have N-butyl L-lactate, which is sold under the name Purasol BL, or 2-ethyl hexyl L-lactate is also cited in the patent, with some others. The water immiscible second solvent is the same as what's in one, but they say it must be different, so you can't use the same one in both. And what they're trying to exploit really in the end use is the different solubilities in of the active ingredient, and more importantly the ethyl cellulose in those two solvents, and to control the volatility and the thickness of the shell and the release, the ratio of solvent 1 to solvent 2 is important, and some examples are given in the patent itself. The miscible organic solvent again needs to be biodegradable, and they talk about using Agrochemical AMD3L amongst others. The emulsifier again, and the whole of the patent really is based upon biodegradable ingredients, which is where it works in terms of the microplastics regulation. And they again have named a commercial product there, but there are a whole range of different products that you can use. So that was a traditional encapsulation and how that might address the challenge and generate opportunities for microplastics. Where there's also activity and where people think about microplastics in the large run is also in seed coating, and this is a patent from Croda, which is actually a composition patent, and they talk about in the abstract you can read here, it's between a rosin, resin and or starch derivatives and a wax dispersion. We'll get the details of that a little bit later, and it can optionally comprises an active, so it can just be a seed coating to improve flowability of the seed through the drill, but it can also be one where you're trying to put on an active or a nutrient to the seed. And they say it provides the good properties, but it's essentially or completely microplastic free. In the patent they talk about a method of making the formulation and for treating seeds, and we'll come to that in a minute. So what are the claims in this patent? It's a composition patent, so it's rosin, resin and or a starch derivative combined with a wax dispersion, and when they're together they're between 2 and 60 weight% of the total weight of the film coating composition. They, as you would expect, have some specifics around what should be done. So the rosin resin has a softening point between 10 degrees C and around about 100 degrees C, and the molecular weights claimed are between 300 and 3,000 grams per mole. Starch derivatives include starches and dextrins, including circular dextrins, which can also be used obviously for encapsulation, and maltodextrins. They claim a range of waxes, and with most formulation patents there's mixtures claimed. Some of the waxes cited include carnauba wax and vegetable waxes. Both of these resins, or all components, starches and waxes, can also be in the form of dispersions or emulsions. As with many things, a formulation is not just what's in the claim, but there are optionally other components such as diluents and carriers, disintegration agents, so that's where you want the seed to maybe start to germinate. You need wetting agents in there to sometimes wet the formulation out. You might need some dispersants in there depending upon what else is in there. Often if they're water-based anti-foam agents, you need then viscosity modifiers, particularly if it's a dispersion. Slip additives can be put into the formulation again to allow it to the seeds to flow over one another, and preservative, particularly if it's a water-based formulation. Seed coating, I always find fascinating that they put in some pigments, and they have pearlescence, and they mention a range of particle sizes, aluminium, and then reds, greens, blue, yellow, orange. So the whole spectrum and whole gamut, as you would expect in a seed coating, is possible in terms of pigments, and that's why in many ways you might need these dispersants and you might need viscosity modifiers, because they're solid particles that need to be kept apart and suspended in the formulation. You don't have to use pigments, you can use dyes, and again they talk about anthraquinone, phthalocyanine dyes in there. And let's not forget, as we talked again before, there can be active ingredients in there. There can also be nutrients, both micro and macro. There can be fertilizers, and there can be biostimulants. We maybe should have said right at the beginning, how do they actually define microplastics? Well, it's referring to a composition of solid polymer. They've used the EU where more than 1 to 1% have a certain dimension between 1 nanometer and 5 millimeters, and the fibers can also be a different length with a length to diameter ratio. As is in the pending regulation in the EU, it doesn't apply to naturally occurring and not chemically modified, and not include polymers that are biodegradable. So they are not captured by the microplastics regulation, and that's mentioned specifically in the patent and in some of the regulations. So in this final section, I'm going to talk to you about biological products and biocontrol. But before we go there, I think it's important to actually look at some definitions, and there are lots of definitions around within biological products. I like this one in particular for Dunham and Trimmer that was presented by Mark Trimmer at ABIM in 2023. We've got biostimulants here with microbials and non-microbials and how that's broken down. Then we have biopesticides under the biocontrol, which is macro and micro, and we're going to talk within biopesticides, not the biochemicals, but we're going to talk about microbials, which is where a lot of the effort is going in to try to improve the performance of biological products through the use of formulation. So there are issues or challenges or opportunities with microbial biocontrol agents, and those that are cited often are wetting or rain resistance or UV resistance. And I'm going to give you an example of where formulation can help with each of those. In terms of wetting, this is something that was published just in July of this year by Momentive, and it's talking about biological, how their adjuvants for tank mixes and in can formulations can help with the wetting out of microbials. And that they've used a little bit of dynamic surface tension here. So you've got surface age on the x-axis and the surface tension on the y-axis. And you know, the straightforward one without any of their additives is the red one on the top. And then you've got an increasing level, and each graph is for a different additive, and how the increasing amount will lower that surface tension. And if you want something to wet out on leaves, we often talk about the surface age being somewhere between 60 and 100 milliseconds that the drop has to wet out on the surface. So this is quite key, and you can see how that is significantly improved with both of their additives in tank mixes and in can. So that's wetting. They also demonstrated here particularly with BT, and they tried to show how by itself a formulation here, and they've outlined where it was on with different additives, how it wetted out. So here you can see the improved additives with Silwet 408, Silwet Eco, and then AgroSpread Flex, and that is again showing how the BT will have improved wetting with their additives and address the challenge or the perceived weakness of some of these formulations. Rain resistance, and here from another supplier, Ingevity, talking about their novel sticker adjuvant, again just from an AgroPages article March of last year. Again, you've got use rate here along the x-axis, and you've got the total retention on the y-axis. And this was after they actually simulated rain fastness with an SC for a BT suspension concentrate formulation. And you can see here how immediately you get an improvement in terms of the retention when you start to add in. And yes, there is a little bit more, up to 0.4%, but you can see with just a small amount of this sticker adjuvant, you get an improvement in the rain fastness. UV resistance has been often claimed to be weak with BT formulations. Again, this is a pattern this time, encapsulation of insecticides, okay, the BT, into biopolymer capsules assigned to, that's the University of New Mexico Rainforest Innovations. They use these natural polymers, cross-linked chitosan beta-glucan or alginate, and they encapsulate the BT together with essential oils and oil components that will be lethal to the larvae and the adults of pest insects, and this is particularly for mosquito larvae. And how does that get released? It's often an issue when you're actually encapsulating something. You need to release it, and they claim that it's released upon hydration or through direct physical contact with the insect or the larva. How do they gain the UV agents? Because in many ways it's encapsulation, but what's improving the UV? Well, they name a whole load in effective amounts, different compositions, and I'll leave you to read those, but some of those India ink, zinc oxide, titanium dioxide and silicon dioxide are well known to actually improve UV resistance, but they're therefore in the capsule. They add them during the synthesis, and it's often spray dried, so you can imagine that UV protecting agent is in that shell of the spray dried capsule. So I hope today I've managed to give you an indication of what formulation can do to address a number of challenges and a number of opportunities. In summary, and this won't change, if we're invited back next year and we want to talk about challenges, I suspect we'll be saying the same types of things are affecting the agrochemical formulators. Some of them are internal, some of those are external. But I want to emphasize that those challenges also bring opportunities for improved business. How can you do that? Well, there are technologies, and I hope I've shown you there are also some new ingredients that provide those new tools for the formulators to address the challenge and deliver new opportunities to your business. I think because of all of these, that agrochemical formulators I believe are very undervalued, but they have a very bright future, because you cannot continue to get business without actually good formulators and good formulations. So that's all I had to say for today. I want to thank you for your attention. I hope you enjoy the Congress. Apologies that I can't be there, but I hope that this has added to your experience. We're happy to talk to anyone in the audience about formulation challenges. When you get the slides, you'll see the contact details for Jim and myself, and you can email us at info@iformulate.biz, or you can look on our website where you'll see lots of webinars, case studies, quotes, etc., and you can find that www.iformulate.biz. So once again, thank you for your attention. Enjoy the rest of the Congress, and goodbye.